So for our last example, we're going to look at this one. I need to find the number of turning points. So I've got a turning point here, and I've got a turning point here. So that's something weird is going on here. So I've got two turning points, which means the smallest possible degree that this could be is going to be an x cubed. But we're going to be careful about that. Okay, so I know it's an odd degree, but we're going to come back and we're going to question this for a second. Why am I going to question this? Because of this little hiccup that's going on right here. So I know it's an odd degree because this arm is going up and this arm is going down. So they're going in opposite directions. I also know it's going to lead off positive. And so we're going to start off by looking at our lead coefficient, which we'll get to in a second. We know that it's positive. But we're going to find the lead coefficient in a second. So first of all, I need to know what my x-intercepts are. I've got one at -3. I've got one at -2. So my x-intercepts are at -3, 0, and at -2, 0. And then I have this one right here, which is a positive 1. So I've got a 1, 0, and then my y-intercept is going to be right here at -1. So I've got a y-intercept at 0, -1. So looking at this, again, let's look at this little weird thing that's going on right here. In the one before that we did, we knew that this was going to be quadratic, or it was going to have multiplicity of 2 because it looked like a parabola right here. Well, on this one, it's cutting straight through. He looks like a cubic function, so he's going to have multiplicity of 3. So that's going to give me a total of 1, 2, 3, 4, 5. Okay? So I'm going to end up with a 5th degree polynomial because this little hiccup that's going on right here. So if we look at this one, it cuts straight through like a line does. So it's a 1st degree. It has multiplicity of 1. If I look at this one, it cuts straight through like a line does. So it has a degree of 1 or multiplicity of 1. If I look at this one, it does cut through, but it has that little hiccup right there, which means that's going to be a 3rd degree. So looking at this, I now can put all of my pieces together. So if my solution is -3, my factor is going to be x plus 3. If my solution is -2, my factor is going to be x plus 2, and those degrees are 1. And then this one is going to finish this up. If my solution is +1, my factor is x minus 1, and it's going to have a degree of 3 because it doesn't cut just straight through. So with this information, I am going to find out using the y-intercept what my value is for my a value. So I've got a -1, so here's my x and my y, equals a times 0 plus 3, 0 plus 2, 0 minus 1 to the 3rd, because that little hiccup. And now I've got a -1 equals a times 3 times 2 times -1 to the 3rd. So -1 equals a times -1 times -1 times -1 is -1. So I get 6 times -1. So -1 equals -6a. Divide both sides by -6, and I get 1/6 equals a, which you cannot see. Okay, so there's my 1/6 equals a. So I'm going to come back up here, and I'm going to say my function is 1/6. So I knew that my leading coefficient had to start off positive, which it does. Okay, I know it's either a 3rd degree or something bigger. So if this had just cut straight through, if that little hiccup wasn't there, I would have said that this was a degree of 1 right here. Okay, but since it had the hiccup, I couldn't make it a degree of 2, because first of all, that would look like a parabola, and second of all, that would give me 1, 2, 3, 4. So that would give me a 4th degree, which doesn't match up with the arms. So the next option is to go one more bigger, which is an x minus 1 to the 3rd. Okay, so that is the final one for that one, and then we'll finish it up with a final video.